Today is the 6th, and today we're going to be talking about rates of change with calculus. So before we actually get into the calculus vocabulary, the calculus examples, we do need to review some algebra terms. And for those of you who didn't have an algebra teacher, I hope this makes sense. If not, you're going to have to like come during office hours or something early. Okay? As we were working with in the do now, the first thing we need to talk about is slope. The definition of slope is the value that describes the steepness of a line. The value that describes the steepness of a line. If we have 2 points, x1, y1, and x2, y2, we can use the formula. Am I going too fast? Okay. We can use the formula y2 minus y1 over x2 minus x1. This formula will give us the slope of a line. And remember that symbol is M. M stands for slope. Okay? But in calculus, it is not uniform. Calculus, for the most part, is not uniform, meaning that everything's not going to be a straight line. It's not going to be constant. We're going to have curves, we're going to have square roots, we're going to have tons of different things. And because it is not a straight line, we're going to need to find something called the average rate of change. And we'll get to that in a second. Also, in calculus, we don't just use y2, y1, because we'll have functions. So we have another formula. This is for functions. F of x2 minus f of x1 over x2 minus x1. These things are for functions. So if we don't have a graph, you're going to need to evaluate and simplify. And we'll talk about this in a minute. Evaluate. Okay? We'll talk about that in a minute. And in calculus, we don't use slope, like I said, because slope implies that it is a straight line. We use, so for rate of change, we use the following symbols. Delta y over delta x. Does anybody know what the deltas mean, what the triangles mean in math? Stop. Or physics. Use the same definitions for the symbol. Huh? Okay, or not. The delta, or as you guys call it, the triangle, means the change of. So we're going to be looking of the change of the y values divided by the change of the x values, right, Crystal? We're going to do change of y divided by the change of x. So, slope, rate of change, delta, the change of. That is all the same thing, but we can use it for different curves, different graphs, different functions. This formula implies you can only use it for linear, but as you can see, we're looking for the change of y's and divide by the change in x's. That's why we can use it in calculus. Okay. Am I going too fast? Crystal, stand up. Do you want a clipboard? There's a bunch over there by the calculators. Okay. The next vocabulary word we need to review is the y-intercept. Anybody know what the y-intercept is? On a graph. Anybody know what a y-intercept is? No? Yes? No? Where are your glasses?
Still broken.
Oh.
I'm getting new ones on Friday.
Okay, good. The y-intercept is the point where a graph crosses the y-axis. The point where the graph crosses the y-axis. The coordinate for that, is going to be 0, comma, y, where y is some value on the y-axis, okay? So if I had a graph here, this would be the y-intercept at 0, comma, y. So if the y-intercept crosses the y-axis, where do we think the x-intercept crosses? If the y crosses the y, where does x cross? If the y crosses the y, where does the x cross? Yes, x-axis. I heard somebody whisper it. Why can't we just talk louder? The x-intercept is the point or points. We can have multiple on the x where a graph crosses the x-axis. Am I off screen? A little bit? That coordinate is x, comma, 0. So I can have one here, x, comma, 0. I can have one here, x, comma, 0. Am I off screen? I can have one here, x, comma, 0. I cannot have multiple y-intercepts. I cannot have multiple y-intercepts. That means it's not a function. Okay, so this is a review of the vocabulary. Review of the vocabulary. I think so. Ask Mr. Esquivel, see if anybody else is in line. Diego. Okay. Let me know when you're ready. When you're ready. So now we're going to get to new vocabulary and examples. Good? Ready? Ready? Okay. Alright, so new vocabulary. So this is new vocabulary for calculus. New vocab. When we talk about slope, again, we're talking about having a line. But calculus, like I said, is not just going to be a straight line. Calculus deals with a number, like unlimited number of functions or graphs. So if we want to find the slope or the rate of change between things, we need to find the average rate of change. Average rate of change. I'm going to abbreviate this so you're going to see from this point on as ARoC, average rate of change. The average rate of change is the rate of change over an interval on a curve. But Miss Santana, I don't understand the word interval. Well, that's okay. Interval is, sorry, lost my train of thought. Is a range of values. Okay. Interval is a range of values. It is denoted by the following brackets, not parentheses. So when you see brackets, that is an interval. Brackets are intervals, meaning that it's going to go from one point to another. So we're going to go from x1 to x2. That is what an interval is. So an interval is a range of values, and you're going to know it because of the brackets. You're going to know it because of the brackets. This is your starting point. And this is your ending point. The start and end. Start and end. So let's say we have a curve. Am I going too fast, guys? Am I going too slow? Yes? Who's going to say yes? Let's say I have this graph, okay? It's not perfect, whatever, it is what it is. The reason we have average rate of change is because the slope or the rate of change between these points, so the slope between these points will not be the same between these points. And that is why we have average rate of change, because there will be some times when we need to evaluate or examine both of these things. They will not always be the same over intervals. Average rate of change may not be the same over all intervals. promise we have a few more notes and then we'll get to examples and then practice, okay? Oscar. Thank you. You guys just give me a thumbs up when you're done, so I know. Okay. Once you put it up, you can put it down. Ready? Everybody over there ready, Mr. Esquivel? No? Okay. Yeah? Okay. Alright. So now let's talk about what level 1 will look like. So level 1 will be finding average rate of change with graphs or functions So you're going to have steps. I'm going to give you steps. First step is to find the coordinates. Find the coordinates. You're going to be given an interval. Yeah, it's Moana. So you're going to be given an interval. All right, remember, this is going to be your first x. This is going to be your second x. Meaning that you're going to need to find your x1, x2. Well, I'm sorry, they gave you x1, x2. And then you need to find your y1, y2. So you get your x1, x2. You have to find your y1, y2. If you have a graph, on a graph, all you're going to do is you're going to find where the x meets the curve. Easy. All you're going to do, you'll see in a second, is trace to where that point is. If you have a function, you need to evaluate by substituting. Mr. Esquivel. Alex. He's been gone for a while. Step 2 is you're going to substitute the coordinates correctly. Coordinates. I think I spelled that right. Into the slope formula. And then, last but not least, you are going to just simplify. We want reduced fractions. Alright, when you're done copying that down, take out your example sheets and do a couple examples. Did I pass out example sheets? Right? Did I give you them? Can I go? Ready? All right. Let's look at example 1. Okay. So we have a graph here. We can use our coordinates to find the other points. What did I say that this is going to be? And on the interval, this is an interval. What did I say these two things are going to be? x1 and x2. Very good. So I already have half my coordinate. So I have negative 1 comma something and 0 comma something. On a graph, all we're going to do is we're going to find negative 1 on the x-axis because these are x's. And then we're going to go to, we're going to find negative 1 on the x-axis and go to where it crosses the graph. Okay, so here's negative 1. If I go up, negative 1 crosses the graph at this coordinate. What is that y coordinate? 1. Very good. Questions on that? Are we sure? Are we sure? Okay. Now we need to go to 0. 0 is here. Then we go up to where it meets the graph. Where does it meet the graph? Also 1. Questions? So this is x1, x2, which means that this is what? y1 and y2. Very good. Questions? We sure? Okay. So that was step 1. We found the coordinates. We had the graph and we found the coordinates. What is step 2? What is step 2? Thank you for looking back at your notes, Crystal. Substitute the coordinates where? Into the slope formula. So your slope formula is y2 minus y1 over x2 minus x1. Am I off screen? Yes, I am. All right, so let's substitute them. What's y2? What's y2? 1. What's y1? 1. What's x2? 0 minus x1. Negative 1. Questions? We sure? And now, what is step 3? Simplify. Use your calculator. Use your calculator, okay? When you put this into your calculator, you will get 0. Yeah, you'll get 0. How do you put a fraction in a calculator? Alpha y equal. If you don't remember that, write that down. Alpha y equal, alpha y equal, alpha y equal. Okay? Questions? Are we sure? Sorry, I was reading the text. Are we good? Are we sure? Okay. For sake of time, and so this way you can get some practice in, we're going to move on to C and D. Okay? Do I have a graph for C and D? No. I have functions. So we're going to still follow the same steps, but we're going to not use a graph. We're going to use the function. So step 1 says to find the coordinates. What are these called again? Yes, it's an interval, but what's on the inside of the interval? X, X1, X2. Good. X1, X2. So again, I have half my coordinates already. -1 comma something and 0 comma something. But I don't have my graph. That's okay, because I can still find the coordinates of those things by substituting in the value to evaluate. So I'm going to take -1 and I'm going to substitute it in for t. So I'll put -1 squared plus 1. And we've been doing this forever. We did this in our last skill. When you do that, that will give you 2. Trust me. I've done it a million times already. So that's going to give you 2. If you can't do it in your head, that's okay. Do it in the calculator. So what will this then be? What part of my coordinate will this be? So -1 goes with 2, so I have to put it here. So if this is x1, what's this going to be here? y1. Questions? Okay, now I'm going to do 0. 0, same thing, you're going to substitute it in. So it gives me 0 squared plus 1. And that will be 1. So this is my x2, which means this is my, if this is x2, this is what? y2. Questions? Questions? Okay, so now we've done step 1. We found our coordinates. What's our step 2? What's step 2? La, da, da. Substitute the coordinates into the slope formula. So we have y2 minus y1 over x2 minus x1. Somebody tell me the numbers I should be putting in. What? Nope, not 1 minus 2. Oh yeah, you're right, my bad. 1 minus 2, sorry. Over 0 minus -1. Don't forget to put these in parentheses. Don't forget to put these in parentheses. When you put that in your calculator, you get -1. How do you put a fraction in a calculator? Alpha y equal. Questions? Crystal? Okay, do we have a graph for D? What did we have then? Equation or a function. So I need to substitute in again. Seniors, again, fractions are okay. Don't freak out. Fractions are okay. Fractions are okay. What does 0 stand for? X1, what's 1 stand for? X2, so we have 0 and 1. How do I find y1 and y2? What'd you say? I'm off the page. Thank you. Thank you. How do I find my y1 and y2? Starts with an S in your notes. Substitute. So I'm going to substitute in 0. So I get -1 over 0 plus 2. gives me negative 1/2. What's the next thing I should substitute in? 1. So I get negative 1 over 1 plus 2. That's going to give me negative 1/3. Questions? Are we sure? All right. Step 3, what do we do? I'm sorry, step 2. We're not on step 3 yet. Substitute what? Into the slope formula. Very good. Sorry. y2 minus y1 over x2 minus x1. It is okay for fraction. So if you put this in your calculator, you're going to have to do the fraction twice. Negative 1/3 minus, said 1/3 and wrote 1/2, minus negative 1/2 over 1 minus 0. And when you put that into your calculator, you get, I don't know, I think that's 1/6. Questions? Are we sure? We're sure. All right. Once you're done copying this down, flip over. You have enough time to do the